Logarithms, an introduction. A logarithm is just a slightly different way of looking at an index or power. We know, for example, that 10 squared, 10 times 10, is 100. It says that 10 raised to the power 2 is equal to 100. Whereas, if we write log to the base 10 of 100 is 2, that says that when the base is 10, to get 100, we have to raise it to the power 2. We can use the above statements to make a general definition of what a logarithm is. Look carefully, pause the video if you have to, at the position of the 10, the 100 and the 2 in each of these statements made above. And then consider that we have a base of A, a power B and a number C. So in other words, the A is going to replace the 10, the B is going to replace the 2, and the C is going to replace the 100. A to the power B is equal to C if and only if log to the base A of C is equal to B. So this works in both directions, which is what the if and only if shows us. This is so crucially important. It's really important that you note this down. It's the actual definition of what a log is, and we can answer many, many questions if we just understand this. Y equals log to the base A of x is the inverse function of y equals a to the x. So logarithmic functions and exponential functions are inverses of each other. In particular, in the first section, we are going to be dealing with base 10 logarithms. A base 10 log may be written as log to the base 10, or if you ever just see log, then it's implied that it's a log to the base 10. And sometimes, and particularly in the textbook, it's just written as LG. As they are inverse functions, the graphs are reflections of each other in the line y equals x. So here we have a graph, and this is the graph of y equals 10 to the power x here. And we've dealt with exponentials before, so we can see the negative x-axis is an asymptote. It goes through 0, 1, and then goes off here very, very steeply. This here is, well, first of all, we have the line y equals x. We know that functions and inverse functions are reflections of each other in the line y equals x. And this is y equals log to the base 10 of x, which we can see is the reflection of this one. So its asymptote is the negative y-axis, and it goes through the point 1, 0.